Next topic, convex and concave polygons. Okay, convex and concave polygons. Done. Now, a polygon. Okay, a polygon is said to be convex if all its interior angles, okay, are less than 180 degree, and if it does not satisfy, that means any one angle, if it is more than 180 degree, then it is a concave polygon. Look at some polygons. Look at this one. This is a polygon. Look at this one. This is also a polygon. Now here you see, suppose this is, it's a triangle. Suppose this angle is 70, this is 30, this is 80. So the three angles are less than 180. Okay, in this polygon all the angles are less than 180, so it is a convex polygon. Look at this polygon here. This angle, okay, suppose this angle is 30. Okay, suppose this angle is 20. Done. Suppose this angle is 60. Okay, and you see this is having 1 2 3 4 sides, so this is a quadrilateral. And suppose this angle, all right, suppose this angle is 200. Okay, suppose this angle is 250. Okay, now see the angles here. This is less than 180, less than 180, this is also less than 180, but this angle is more than 180 degree, 250 degree. So since one angle is more than what is that, 180 degree, so this is a concave polygon. So this is convex, and this is concave. So if all the angles are less than 180 degree in that polygon, in the particular polygon, that polygon is known as convex. If any angle is more than 180 degree, any angle, okay, then it is known as concave polygon. Okay, another one important property, and you can even identify by using that property in convex polygon. Okay, in convex polygon, the diagonals lie in the interior. Okay, so diagonals lie in the interior means, what is diagonal? I'm coming to this point. Okay, so diagonals, look at this point as well. So diagonals, suppose this is a quadrilateral. Okay, ABCD. Now in a quadrilateral, in this quadrilateral, if you join the opposite vertices, okay, the line segment joining the opposite vertices is known as diagonal. Now A and B adjacent vertices, A and C opposite vertices, or even we say not always opposite, we sometimes say non-consecutive vertices. So A and C are non-consecutive vertices joined by this line segment. This line segment is a diagonal. B and C consecutive, B and D opposite or non-consecutive vertices. So if you join this line segment is known as diagonal. This is what diagonal is. Okay, now look at this figure ABCD. What you have seen, diagonal AC and diagonal BD, they lie in the interior of the figure ABCD. The diagonals lie in the interior. So if diagonals lie in the interior, you can identify this polygon as always convex. Okay, so if all the diagonals lie in the interior, okay, in a polygon, then that particular polygon is known as convex. Concave, you see, supposing this figure only, you look at this, what I was saying, the diagonals are the line segment joining any two non-consecutive vertices. So suppose this is L, M, N, P. Okay, this is the name of this quadrilateral. 4 sides, no? So it's a quadrilateral. Now, if you join the non-consecutive vertices, you see M and N consecutive vertices, you cannot join. N and P consecutive vertices, you cannot join. Okay, but M and P, they are non-consecutive vertices, so you can join. Now if you join this is the diagonal, because diagonal definition is only that if you join the line segment joining any two non-consecutive vertices is a diagonal. So I have joined this M and P, they are non-consecutive vertices. Then you go P and L consecutive. Okay, then L and M consecutive, L and N non-consecutive. So you join it. This diagonal is in the interior, this diagonal is in the exterior. Any one diagonal or any one part, any part of a diagonal, okay, or some parts of a diagonal or some diagonals, if goes outside like this, because this was the original figure. This diagonal has gone outside, exterior. If any diagonal, or if some diagonals, or if some part of a diagonal, okay, go outside, then that polygon is known as concave. So this is a concave polygon. You can even identify like that. How? By drawing the diagonals. So diagonal goes outside, concave. All diagonals in the interior, convex. I hope you have understood. Actually, basic definition is this: all the angles are less than 180, convex. This is how you can check it. All the angles are less than 180, convex. If even any one angle is more than 180 degree, then it is a concave polygon. Done. Now diagonal. The diagonals definition already I have given. What is that I said? That non-consecutive vertices should be joined. Another figure if I draw, okay, look at this figure here. So this is your A, B, C, D, E, having 5 sides, so it is a pentagon. Now this in this polygon, if you try to draw the diagonals, definition of diagonal is the line segment joining any two non-consecutive vertices. But the vertices not should be taken, not what is that? Those vertices should be taken which are not in serial order. Okay, so that is what non-consecutive. A and E cannot be taken serial order. A and D can be taken. Join it this line segment. Okay, it's a diagonal. So all non-consecutive you try. A and C non-consecutive. B and D non-consecutive. E and C non-consecutive. B and E non-consecutive. So when these non-consecutive vertices are joined, those line segments are diagonals here. So here the diagonals are AC, if I name it AC, then AD, okay, then BD, BE, BD, then BE, BD, BE, and also I can take CE, C. So these are the 5 diagonals. Non-consecutive vertices should be joined. Now we have a ready-made formula to find the number of diagonals. Find the number of diagonals in a polygon. Now in this pentagon, it was having 5 sides. So 1, 2, 3, 4, 5 sides. In this pentagon, I got the number of diagonals. How many? I got a number of diagonals 5. So without drawing the polygons and without drawing the diagonals, even using this formula, we can find the number of diagonals. So the formula is like that: number of diagonals of a n-sided polygon. Okay, of a n-sided polygon. Okay, the formula is n into n minus 3 divided by 2. So this formula can be used. Already I have given in the note. This formula can be used to find the number of diagonals in a polygon. But remember, while finding the number of diagonals, this polygon can be convex or concave, doesn't matter. Only you need to see how many sides are there. Now if I explain this this formula for this, because already I have got 5 diagonals, if I try to check this formula for this pentagon, look at this. If I check it for this, already I have got how many? 1, 2, 3, 4, 5. See, using the formula I get or not. N how many? N is pentagon, no? N is the number of sides. So this is a pentagon, 5 sides. 5 into, then n minus 3. N you put 5. 5 minus 3 divided by 2. So this is equal to 5 into 5 minus 3 is 2. This is 2. 2 and 2 get cancelled. So what is the answer? 5. How many diagonals? 5. By drawing I got 5. Without drawing, directly by using the formula n into n minus 3 divided by 2, you can directly get the number of diagonals, and this formula gives here the number of diagonal is 5. Okay.